Fractional Orbital Bombardment System, FOBS, a silent weapon orbiting above Earth, ready to strike without warning. This isn't science fiction, it's China's emerging real-world threat. Their development of space-based nuclear missiles using FOBS technology has Pentagon officials alarmed and scrambling. Why? Because these missiles don't follow the rules. They're unpredictable, faster, and harder to stop. In this video, we'll break down what FOBS is, why it's revolutionary, and how the US plans to respond with the ambitious Golden Dome missile defense shield. In the world of advanced missile technology, FOBS, or Fractional Orbital Bombardment System, is a serious disruptor. Unlike traditional intercontinental ballistic missiles, ICBMs, which arc high into space and follow a fixed, predictable path to their target, FOBS takes a far less conventional route. It sends a missile into low Earth orbit (LEO), allowing it to circle part of the globe before deorbiting and striking its target. This method gives it a unique and dangerous advantage. It can hit without warning and from any direction. This unpredictability makes FOBS especially concerning for defense analysts. Most missile defense systems, particularly those in the United States, are designed to track threats coming over the North Pole, the most common ICBM route. FOBS, however, can attack from the South Pole or even through off-axis orbital paths, entirely bypassing early warning radars and rendering traditional tracking systems almost useless. The concept isn't new. The Soviet Union tested a similar system in the 1960s with the R-36O missile. But treaties like the Outer Space Treaty of 1967 and SALT II in 1979, along with technological limitations, caused the program to be phased out by the 1980s. Fast forward to today, and China has not only revived the FOBS idea but may have taken it to the next level. In 2021, China shocked the world by launching a Long March 2C rocket that deployed a hypersonic glide vehicle, HGV, into orbit. It circled the planet partially, then re-entered the atmosphere and successfully maneuvered toward a ground target. This combination of orbital mechanics and hypersonic speed was something no other nation had demonstrated in this way. What made it so alarming was the precision, speed, and stealth of the test, a fusion of two cutting-edge technologies. According to U.S. military leaders, including then-chairman of the Joint Chiefs of Staff Mark Milley, this event was very close to a Sputnik moment, signaling a potential strategic gap. It raised immediate questions. How do you defend against a missile that can fly anywhere, from anywhere, and at speeds that render interception nearly impossible? While FOBS may be the headline grabber, it's just the tip of the iceberg in China's rapidly growing missile capabilities. A recent report by the Defense Intelligence Agency, DA, laid out some eye-opening numbers. By 2035, China could have up to 60 FOBS systems, 700 nuclear-tipped ICBMs, 132 submarine-launched ballistic missiles, SLBMs, and 4,000 hypersonic glide vehicles, HGVs, a massive leap from the roughly 600 HGVs they have today. This is a massive expansion, and it signals not just a race for military parity but a possible bid for strategic superiority. For comparison, Russia is expected to maintain around 12 FOBS, 400 ICBMs, and roughly 1,000 HGVs in the same timeframe, significantly less than China's projected numbers. These figures suggest that China is moving aggressively to challenge the United States not just in conventional power, but in nuclear and strategic dominance. What makes China's growth so alarming isn't just the numbers, it's the technology behind them. Hypersonic glide vehicles can travel at speeds exceeding Mach 5, but their real advantage lies in maneuverability. Unlike standard ballistic warheads, which follow fixed arcs, HGVs can change course mid-flight, weaving around interceptors and radar detection zones. Combine this with a FOBS launch profile, and you have a weapon system that is nearly impossible to predict or block. Additionally, China's investment in submarine-launched ballistic missiles indicates a push for second strike capability, which is key to nuclear deterrence. Their modern Jing-class submarines are already equipped with JL-3 SLBMs, giving Beijing the ability to launch nuclear weapons from the ocean, far from mainland surveillance and retaliation. According to the DIA's May 2025 threat assessment, China is not only focused on quantity, but also on quality, range, and survivability. Some of their newer systems already have the ability to strike U.S. territories such as Guam or Alaska, and they may soon target the continental United States with minimal warning. Faced with China's accelerating missile capabilities and the game-changing threat of FBS, the United States has launched an ambitious initiative, the Golden Dome Missile Defense Program. Announced via executive order by President Donald Trump in January 2025, this system aims to be nothing short of revolutionary, a space-based shield that can defend against missiles from air, sea, land, and orbit. While the concept of a missile defense umbrella isn't new, Golden Dome marks a significant leap in scale and scope. Unlike the ground-based mid-course defense, GMD, or THAAD, which are terrestrial systems, the Golden Dome envisions a constellation of satellites, orbital interceptors, advanced radars, and potentially directed energy weapons. According to the executive order, 2 key satellite programs have already been prioritized: Hypersonic and Ballistic Tracking Space Sensor (HBTSS), Proliferated Warfighter Space Architecture (PWSA). These would provide early tracking of threats like FOBS and HGVs from orbit, enabling much faster response times than ground-based radars. The goal is to intercept missiles during their boost phase, the moment they're launched, or to track them seamlessly across long distances and high speeds. But there's a cost, a very big one. The Congressional Budget Office recently estimated that developing and deploying the Golden Dome could cost up to $542 billion over 20 years, making it one of the most expensive defense projects in U.S. history. Despite this, Congress has already earmarked $24.7 billion as part of a broader $150 billion boost to Pentagon funding. Supporters argue that with threats like FOBS, there is no alternative. The risk of being unprepared is too great. Opponents, however, are skeptical. Critics point to the technical hurdles of intercepting orbital and hypersonic weapons, the vulnerability of satellites in wartime, and the lack of a clear architecture for how Golden Dome would actually work. Even Representative Ken Calvert, chairman of the House Defense Appropriations Subcommittee, admitted no one has defined what the Golden Dome is. Still, the initiative reflects a broader strategic shift. It's not just about stopping missiles, it's about preparing for a future where space is a battlefield. The emergence of FBS and hypersonic weapons marks a significant shift in global strategic dynamics. These technologies challenge existing defense systems and necessitate new approaches to deterrence and defense. China's rapid development of these capabilities underscores the urgency for the United States and its allies to adapt and innovate. The proposed Golden Dome missile defense system represents one such effort to address these evolving threats. While it faces technical and financial hurdles, its development signals a commitment to maintaining strategic stability in an increasingly complex security environment. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.